guys, welcome back. I have a special surprise for you. Just a minute. I got a puppy! Isn't he just the cutest? My heart is so happy right now. And fun story, I just got him yesterday afternoon. He's already pooped on a rug. I love it so much. But I just wanted to say hi. He kind of follows me around like my shadow so far. And maybe if you can guess his name, I'll give you a bonus point. So send me your guesses. But also, I just have a name in mind. So if one of your guesses is better, maybe I'll go with the name that you suggest. But we'll see. So this is my newest friend. And maybe he'll be making appearances in my videos from now on. He's a little sleepy right now, so I'm going to put him back. All right. Okay, so today we're factoring part 4, lesson 7. Yesterday, or whenever you watched lesson 6, we were factoring when the leading coefficient was 1. So now we're going to factor trinomials when your leading coefficient is not 1. So what is the first step of factoring? Still checking to see if you have a common monomial. The second step of factoring, I haven't taught you yet. We'll come back to that in a later lesson. I think it's actually lesson 8. And then the third step of factoring will be to see if it does have a leading coefficient of 1. And if it does, then do the x factor like we just did in lesson 6. Step 4 of factor would be if your leading coefficient is not 1, and you followed the first 3 steps, then you're going to do what we're doing today, which I call the X and box method. I learned this from my high school math teacher. She was an excellent math teacher. Shout out to her. And so I just wanted to share this knowledge with you. All right, so we're going to first review by using the box method to multiply these two binomials. So if you recall, there are 2 terms, 2 terms. So that means you need a 2 by 2 box. The first binomial, 3x plus 1. So 3x goes over the first box, a positive 1 over the second, and then x minus 4 goes along the other side. Multiply like a Punnett square. X times 3x is 3x squared. 1 times x is 1x. You don't really need the 1 there, but you can put it if you want to. 3x times negative 4 is negative 12x. And 1 times negative 4 is negative 4. And so then if you recall, using that box method, you combine the diagonals, which are your like terms, x and negative 12x. So if I have negative 12x's plus 1x, I have a total of negative 11x's. So your final answer would be 3x squared minus 11x minus 4. Okay, so kind of going back to what we did yesterday, or lesson 6, if you're trying to come up with those 2 bubbles from this trinomial, you have to think of that first times first, last times last. What do the outer and the inner combine to give you? So if we were to look at this one, at the trinomial, 3x squared minus 11x minus 4, knowing that we were trying to get 2 bubbles from that. Well, the only way that we could get something times something and get a 3x squared, you would have to list the factors of 3. So this one's an easy one because 1 and 3 are the only factors of 3, but can you imagine if we had like 100 here? We would have to figure out all the different combinations that would multiply together to give us 100. 10 and 10, 1 and 100, 25 and 4, okay, 20 and 5. Those would all be different combinations for the first times the first. So that's a lot of guess and check there, but not to mention you also need to know what the last times the last is. And in this case, they were giving us negative 4. So again, smaller numbers, so we don't have as much guessing and checking, but what if that number was like 40? You'd have lots of different factors of 40 that could be potentially put into those 2 spots there. So if you've got like 20 factors for the first coefficient and 20 factors for the second one, you've got a ton of different combinations that could fill in those bubbles. So that's a lot of guess and check. There's a shortcut to that method. Some people call it different things of the guess and check, but the way that I'm going to teach it to you, it eliminates a lot of that guessing and checking. So I call it the X and box method, and I'm gonna just kind of jump into it with you. So this is factoring when your leading coefficient is not 1. You've already factored out a common monomial, your leading coefficient is not 1, so then you use the X and box method. So the X is still present and it's very similar to what we did before, except now since we have some number at the beginning, okay, it's not a leading coefficient of 1, what we're going to put at the top of the X is A times C. So you're going to multiply the first coefficient times the constant. Okay, so at the top of your X, you have the product of A times C. Fish is still alive. At the bottom of the X, you're still going to put B, that middle coefficient. Okay, so at the bottom of the X, B. You're still going to try and come up with the two numbers that multiply to give you the top number and add to give you the bottom. That process is still the same. The only thing that we've done different so far is multiplying A times C. Only thing that's different. So let's say you get M and N. Okay, M times N gives you the product at the top, and M plus N gives you the sum at the bottom. Next, you're not done now. So rather than just plugging those M and N's into a bubble, next you have to plug them into the box. So if you remember, we're unfoiling. So like we just did in this example, we started with the binomial bubble, so we put them on the outside, multiplied, and got the inside part, simplified, and got our answer. So we're working backwards, which means we're going to fill in the box and then pull out the bubbles. Okay, if that makes sense. So basically, what you should notice about that foiling process is the first times the first gave us this top left box, that 3x squared, and the last times the last still gave us that -4, the last term there. And then the outer and the inner, what combined to give us that -11x. So when you fill in the box, that first term is going to go in that top left box. Whatever it is, it gets plugged into the box in that top left corner. That last times last term, the C, is going to go in that lower right corner, just like when we FOILed in this previous example. Our first times our first gave us that 3x squared, which is the first term in our trinomial. Our last times our last gave us that -4, which was the last term in the trinomial. So those come from the trinomial that you're trying to factor. The other two boxes, okay, those are what combine to give you that middle term, and then remember you're coming up with those two numbers that combine to give you that middle term from your X factor. So what goes in those two diagonals are the M and the N that you come up with in your X factor. It does not matter which box you plug them into, but the one thing that you need to do is reattach the variable to it. Okay, so we're just talking numbers here, but those two combine to give you a linear term with an X in it. So your M and your N go in the diagonal boxes, and you must add the variable. So I added my X back in, and added the X back in, okay? So I understand that it might sound super complicated right now because I'm just using variables, but once I go through an example, hopefully that helps you understand a little bit better. All right. So there's that part. Example number 1. Factor the trinomial completely. So first step of factoring. Is there a common monomial? Well, 9a squared minus 56a plus 12. Is there a variable that you can take out of each term? No. This term does not have a variable, so you can't factor out a variable. 9, 56, and 12. Is there a number that you can divide out of all of them? Check and see. 2? No, because 9 is not even. 3? I don't know, maybe. We know that 9 and 12 can divide by 3, but maybe you don't know off the top of your head if 56 does. So plug it in. When you plug it in, does 56 divide by 3 without a decimal? No, it doesn't. Okay. 4, no. 5, 6, 7, 8, 9, no. So there's no common monomial. Okay, make sure you're checking for those. Step number 2 of factoring. I'll write this out on the whiteboard for the next lesson. Step number 2, I haven't taught it to you yet, but I'm going to tell you the answer is no. So move on to step number 3. Step number 3, is your leading coefficient 1? No. So move on to step number 4. If your leading coefficient is not 1, use X in box, which is what we're going to do. So first you draw your X. What goes at the top of the X? Remember, this is the first different step. So you're going to do your A times C. So 9 times 12, which gives you 108. And then what goes at the bottom? Still that middle coefficient, negative 56. So you should be asking yourself the same thing. What times what gives me 108, but when I add them together, I get negative 56. Bigger numbers, okay? What you should notice is that when you're multiplying them, you get a positive, but when you add them, you get a negative. So both of your numbers must be negative. All right, so remember, if you struggle with coming up with those two numbers, list all of the factors of that top number because they must multiply to give you 108. So let's just do that. Let's list all of our factors of 108. 1 and 108. Again, if you're not sure, plug it into your calculator. What's 108 divided by 2? Plug it in right. 54. He's having a puppy dream. 108 divided by 3. 36. 108 divided by 4. 27. 108 divided by 5. 108 divided by 6. 18. 108 divided by 7. 108 divided by 9. 12. 108 divided by 10. 108 divided by 11. 108 divided by 12. Okay, so we're done. Okay, that's our entire list of factors of 108. And now we just need to figure out if they're both negative, which ones add together to give us negative 56. Well, since we're at negative 56, choose the larger set, okay? So what you should realize is that it's negative 2 and negative 54. Because negative 2 times negative 54 gives you a positive 108, but a negative 2 plus a negative 54 gives you a negative 56. So we found our two numbers. Those go inside your X. And remember, you're not done yet. You need to do the box. So we're filling in the box next. And we're going to pull out the two binomial bubbles. So here's our box. We're unfoiling, unboxing, so the first times our first is what's giving us this 9a squared. So you plug that into the box. You're going back to the original trinomial that you're trying to factor. So this 9a squared, top left box. The constant term, the 12, goes in the lower right-hand box. We're not using the 108 at all, okay? We're not even using the negative 56. What we're using for the other two boxes are the two numbers that we just came up with in our X. So the negative 2 and the negative 54. It does not matter which one you put where. Okay, so if I put the negative 54 in that top right box and the negative 2 in the bottom one, it's fine. But you need to remember to attach the variable. So it's negative 54a and negative 2a. Okay, next. I didn't go over that with you here because it didn't really make sense without numbers. So the next thing you're going to do, we've filled in our box, now we just have to get the outsides. Well, what did we actually multiply to get that as an answer? So what I would recommend doing is look at your top row, the 9a squared and the negative 54a. Ask yourself, what is the greatest common factor or greatest common monomial of those two terms? 9a squared and negative 54a. Also, only factor out the positives, okay? This one's positive, this one's negative, so don't worry about the signs, just factor out the positive. I think I have dog hair in my mouth. All right, so 9a squared negative 54a. What number can you divide out of both of them? 9. And then this has a squared, so 2 a's, a times a, and this has 1a. So you can also factor out an a from both of those two. So we're just looking at the top row here. 9a is our greatest common monomial, so we're factoring out, and that goes right out here to the left. And now you're just working backwards through a process of, well, remember that Punnett square, the multiplying? 9a times what here gave you 9a squared? Well, it had to have been an a. 9a times what up here would give you a negative 54a. We've already got the a taken care of, so 9 times what gives you negative 54? Or, if you're dividing, okay, working backwards, negative 54 divided by 9. You should get negative 6. And then this last spot here, it's this a times that spot to give you negative 2a. So a times what gives you negative 2a? Negative 2. And we're pretty much done. Now you just need to put them into your bubbles. So this bubble up here was an a minus 6 bubble. And then this bubble here is a 9a minus 2. And that's your answer. If you would have had a common monomial, you would need to reattach it here, okay, at the end. But we didn't, so that's our final answer. Remember, you can refoil or rebox, remultiply these to see if you got what we started with, and we would. The order that you put the bubbles does not matter. It does matter that you have the a and the minus 6, the 9a and the minus 2, okay? But it doesn't matter which bubble you put first. If you put the 9a minus 2 bubble in front of the other bubble, it's fine. The commutative property is what allows us to switch that order around. So that's the first one. I want you to try example 2 on your own. I'm going to do example 3 with you. Okay, again, check for a common monomial. Leading step number 2, you don't know yet. Number 3, leading coefficient is not 1, so you're going to X in box. Example 3, 15x squared minus 8x plus 1. Okay, is there a common monomial? No. Okay, so x. 15 goes at the top because we're multiplying a times c. So 15 times 1 is 15. And then this negative 8 goes at the bottom. So again, what times what gives you 15, but when you add them you get negative 8. So we've got another multiplying to get a positive, adding to get a negative. Maybe you can come up with that off the top of your head without listing the factors of 15. They're a little bit smaller numbers. What you should come up with is negative 5 and negative 3. Again, that order does not matter. You can put negative 3 before negative 5. Doesn't matter. Next, your box. Fill it in. The top left corner is your first term of your trinomial, so 15x squared. Your last lower box is the last term, positive 1. And then your other two numbers that you just came up with in the x are what get put in the diagonals. They're the ones that are combining to give you that middle linear term. So negative 5x and negative 3x. Again, that order doesn't matter. So looking at the top row, what can you factor out of 15x squared and negative 5x? The greatest common factor, greatest common monomial. You should find that it's 5x. So remember that goes out to the left. And now you're just working backwards. 5x times what gave you 15x squared? 3x. 5x times what here would give you a negative 5x? Negative 1. And then 3x times what here gives you a negative 3x? Negative 1. There are your bubbles. So you have a 3x minus 1 bubble, and you have a 5x minus 1 bubble. Order doesn't matter. If you would have put your negative 3x and your negative 5x in the opposite locations, only thing that would have done is it would have switched the bubbles around. So your 5x minus 1 bubble would have been up here, your 3x minus 1 bubble would have been right here. Okay, it just switches the spots. Doesn't matter. All right. There's your final answer. There was not a common monomial that we need to reattach, so that's the end. Done. Factored. Okay, I'm going to do number 8. Just kidding, this is number 4. I'm going to do number 4 with you as well. 8x squared plus 58x plus 60. 8, 58, and 60? Oh, what you should notice is that those are all even numbers. So step number 1 of factoring, there's a common monomial. Factor it out. If you forget that step and you don't factor out the common monomial, it's not the end of the world. Your numbers will just be bigger. And then at the very end, you should notice in your bubbles, maybe if you had, this is just an example, if you would have like a 2x minus 4 bubble, okay, or like a 3x plus 6 bubble. What you should notice is that in this bubble itself, 2 and 4 has a common monomial of 2, so factor out the 2, and you get x minus 2. In this bubble, it has a common monomial of 3, so factor out the 3, and then you get x plus 2. Since it's all multiplication, 2 times 3, you get 6, and then an x minus 2 bubble, and an x plus 2 bubble. So if you forget that common monomial, you might get something that looks like this, and you should factor that down again. You don't want to be able to factor anything out of the bubbles. If you can, factor it out. That means you forgot the common monomial, okay? And then you could do something like that. I'm not going to keep this on here. I'm going to erase it, so if you need to see it, hopefully you got that. You can screenshot it, pause. Okay. Oh. All right, so we did have a common monomial of 2. We caught it, so we're going to factor it out. And then what's left is 4x squared. 58 divided by 2 is 29. And 60 divided by 2 is 30. Okay, so there we factored out our common monomial of 2. Next, inside here, this is what we're trying to factor down farther now. Leading coefficient is not 1. It's not step number 2, which I haven't taught you yet. So we need to x in box. Okay, 4 times 30, A times C. Think of 4 times 3 and then add the 0 back on. 120. 29 goes at the bottom. Okay, pause. See if you can come up with those two numbers. Okay, and then when you do, hit play and come back and see if they're the same as mine. So again, if you forget, it's what times what that gives you 120, but when you add them, you get 29. You could list your factors of 120. There's a lot of them. 1, 120. Okay, 2, 60, and so forth. But what you should find is that it's, I think, 5 and 24. Yeah. They're both positive, so keep them positive. 5 and 24. Now, plug them into your box. Okay? So you've got your box. This trinomial is the one we're trying to factor, to break down, not the 8x squared one. Okay, so you don't want to plug in the 8x squared, you want to plug in the 4x squared because we factored out that common monomial. This is what we're trying to break down. So 4x squared is what goes in your top left box, 30 goes in your bottom right, and then your 5 and your 24 get plugged in with the variable. I'm going to switch it up and put the 5x there and 24x here. So if we look at that first row, 4x squared and 5x, is there a common monomial? Is there greatest common factor? The only thing that 4x squared and 5x have in common that we can factor out is the x. So factor out the x, and then x times what here, I'll do a different color. X times what here gives you 4x squared. 4x. X times what here gives you 5x. 5. 4x times what gives you 24x? 6. Okay, so you have a 4x plus 5 bubble and an x plus 6 bubble, but we had that common monomial that we factored out at the beginning, so we must reattach it at the end, and that's your final answer. Done. I want you to do example 5 on your own. And number 7. I'm going to do number 6 with you right now. And that will be the last one for today. So example 6. First step of factoring. Is there a common monomial? Yes. Okay. 4x cubed minus 4x squared minus 35x. What you should notice is that each term has at least one x that you can factor out. So factor it out. If you look at the numbers, 4, -4, and -35, there's not a number that you can factor out of both of those. Little guys on the move. All right, so factor out the x. And then what's left? 4x squared minus 4x minus 35. Okay, so you factored out your common monomial. X in box. Remember, you're multiplying a times c, so 4 times -35. -140. And then -4 goes at the bottom. You should be asking yourself, what times what gives me -140, but when I add them, I get -4. You get please. Pen stopped working. You should get -14 and 10. I love it. Out of nowhere, just done. Oh yeah. Ah! Hopefully that worked. Nope. All right, -14 and 10. You should actually be able to finish this on your own. -14, +10, plug it into your box using this trinomial, and then don't forget to reattach the x at the end. So you're also going to finish example 6 on your own now. Just wanted to make sure that you got that common monomial of x at the beginning. Go ahead and practice those. Again, if you have any questions, ask me, email me. I am still planning on sending out an email to all of my classes and telling you how I want you to turn these assignments into me. And if you don't even have the paper yet, you'll be able to pick it up at the packet pickup drop-off that they're doing, that the school is doing, April 14th after Easter break. So I'm going to send you an email with more details on that. And just know that when you're going through these examples, the yellow ones from today's lesson, it's always still possible that one of these is not factorable. And that would mean that you can't fill in the x factor. If you can't come up with those two numbers at all, nothing works, then it's not factorable, and that is possible. So I hope you have a great day, and yep, little buddy's back here sleeping, so I'll have him say goodbye. Again, if you can guess his name, send me an email and I'll give you a bonus point. But for right now, I think I need to go take him out and use the restroom because little guy has not pooped yet today. It kind of has me concerned. So, all right, bye guys. Have a great day.